In this video, we're going to take a look at section 4.7, which is on factoring strategies. So here is our general strategy for factoring when we're presented with a polynomial that we're trying to factor. First, if there is a greatest common factor, factor it out. Second, if there are four terms, use factor by grouping to factor. However, if there are only two terms, use the appropriate formula to factor, which will either be a squared minus b squared, a to the third power plus b to the third power, or a to the third power minus b to the third power, like we saw in section 4.6. If there are three terms, use the AC method or trial and error, or the shortcut if a is equal to 1. Be sure to keep factoring until the polynomial cannot be factored further. So that's really going to be the key in this section, because many of these problems will have multiple layers of factoring. So you'll try one type of factoring, factor it that way first, and then the result you get will have something else that can be factored even more. And you need to continue to factor as long as there is something that can be factored. So make sure you're being persistent and factor as much as you possibly can. All right. So let's try this strategy out on a few of these problems. Okay, so here we have two terms. So most of the, as you could tell from the last screen, most of the time we will be able to determine the type of factoring by how many terms there are. This one has two, which means there must be some formula that will work to factor it. But before we jump into using a formula to factor it, the very first thing you should do on every factoring problem is look for a common factor. And this one definitely has a common factor that we could factor out. So we can factor out a 4. I'm sorry about that. Well, we can factor out a 4, and both of these terms have an x, so we could also factor out an x. That's going to leave me with y squared for the first term, because I'm taking away the 4x, so only y squared is left behind. Minus, the x is going to go away, and then this will get divided by 4, and so we're going to get 64 left over when we do that. So you might use a calculator for that. 256 divided by 4, you get 64. So we did some factoring, and sometimes students on the test, they'll do that. They'll factor out the 4x and they'll say, well, I factored, so I'm done with this problem. But especially in this section, 4.7, there's usually at least one more kind of factoring that has to be done. And in this case, we have these two terms. They can both be written as squares, right? This is y squared minus 64 can be written as 8 squared. And so we have a formula for factoring that. The formula goes like this. A squared minus b squared will factor as a plus b times a minus b. All right, so in this case, instead of a, we have y. Instead of b, we have 8. So this will factor as, we'll still have 4x there. And then we'll have a plus b, which in this case will be y plus 8, times a minus b, which in this case will be y minus 8. All right, and then now we're done, not just because we did one more type of factoring, so that's it, but you look at the result you get, and nothing else can be factored further. Y plus 8 cannot be broken down any further, y minus 8 cannot be broken down any further, so that's how I know I'm done. All right, let's take a look at the next example. So here we have 4 terms. So the method we're going to use for factoring when there's 4 terms is factor by grouping. First, we should look for a common factor. There is no common factor here, so nothing going on in that department. So we're going to try factor by grouping, and we've learned factor by grouping previously in section 4.3. And the general approach to factor by grouping is to group the first 2 terms together, group the second 2 terms together. So why don't we just go ahead and do that real quick just to see where that leads us. Right? And if you're taking notes, you might not want to write this down just yet. So if you group the first 2 terms, always start with a plus sign between your 2 groups. So I'll get negative q squared plus 64. The problem here, the common factor in the first group will be v. That'll leave me with a v plus 16. There is no common factor in the second group. You could, however, factor out a negative sign, and this actually does something. You get q squared minus 64, which is just like the problem we had on the last screen. This will factor as q plus 8, q minus 8, but all of it's for naught because you won't be able to go any further with this. So many students don't understand the mechanism that allows factor by grouping to, finish. What's necessary is that the parentheses from the first group, which is this parentheses here, which I'm doing a bad job of underlining. Let's try that again. This parentheses here has to match the parentheses you have over here, but it doesn't match either one. So there's not a match here, which means I cannot factor out a common factor because these two groups do not have a common factor. And if they don't have a common factor, you're not finishing this problem. You're stuck right here and you can't go any further. And so it's a dead end. It's not factored and you're not going to be able to factor it. What I get the impression for many students when they get to this point is they just feel like they can just pick and choose whatever parentheses they want and just put it all together at the end. So they just take one of everything and slap it together and that becomes their answer. But that is not how factor by grouping works. It works by factoring out the common factor again. So you need to have a common factor in these two groups in order to actually complete the process. And without that, it's a dead end. It doesn't factor. So we're still going to use factor by grouping to factor this, but it doesn't group in the usual way this time. And this is kind of an unusual way to have to group. So I wouldn't, think of using this every time you have to do factor by grouping, but especially in 4.7, you want to keep this option in mind. What we're going to do, first of all, we're going to have to flip-flop these two. So we're going to rewrite it as v squared plus 16v plus 64 minus q squared. And what we're going to do this time is we will group the first three terms together. So instead of grouping 2 and 2, we're going to group 3 and 1. So it's an unusual type of grouping, but it works out in this case, surprisingly. You'll factor the first group. Now this time we won't just factor out a common factor. We're going to have to find two numbers that multiply to 64 and add to 16. And because a is equal to 1 here, we can use our shortcut for getting the answer. This will factor as v plus 4, sorry, not plus 4, v plus 8 times v plus 8. So this actually fits one of the formulas we talked about in 4.6. This is a perfect square trinomial. It factors with the same factor twice, which means we can write that as v plus 8 to the second power. And that's the critical part that makes this work. Because now our first group factors as a perfect square. Our second group was already a perfect square. This now fits into the formula a squared minus b squared, which means we can factor it using this formula. So this time the factor by grouping doesn't work by factoring out the common factor. It works by these formulas that we learned in 4.6. Grouping the first three together lets me factor it as a perfect square. And then once I have the difference of two squares, I can factor it using this formula. And once I've done that, it'll be factored, right? Instead of a, however, we have v plus 8. So that's what I'll have here instead of a. We'll have v plus 8. And instead of b, I have q. All right, so I'll make those adjustments over here on the right-hand side of the formula. Instead of a, we'll have v plus 8. And instead of b, we will have q. And so I'm doing a really bad job drawing these arrows. I apologize for that. Let's try that again. All right. And then, yeah. All right. So that's how you get the answer there. And this will be the final answer because it's factored now because you have two things being multiplied together. That's what you want to have when you have it, to have it factored. Not just two things, but you want to have everything on the highest level of the problem. Everything should be multiplied together. And that's what we have here. And there's nothing else we can do. Like this cannot be factored down any further. So that's how we know we're at the end of the problem. All right, so that's a really tough problem. There's no expectation that you'd be able to figure that out on your own because it would be really hard to see that. So, but now that you've seen it, because that's how I learned it, is I didn't figure this kind of thing out on my own. I had a teacher show me how to do this kind of problem. Now that I've seen it, I can remember that's an option sometimes. So usually I would try this first, group the first two together, group the second two together. But if I see that's not going to work out, I start to get creative and I try to group it in different ways to see if something else will work out. All right, let's take a look at another example. So again, we have 4 terms here, so I'm planning on using factor by grouping. But before I jump into that, we want to look for the greatest common factor. And we actually have one here. Notice that each of these ends in a 5, so I can factor out a 5. That's going to leave me with s to the third power plus 3s squared minus 25s minus, this will be 75. No, that doesn't seem right. Yeah, it is 75. Okay, 75. All right. And this time I will try factor by grouping in the usual way and see if that works out first. And to me, it looks like that should work out. Just looking at this, my initial impression is that the normal factor by grouping will work out. We shouldn't have to do an unusual factor by grouping like we did here, right? So this one still counts as factor by grouping, but it was an unusual, how do you want to say, an unusual alternate method that we had to use. This one, I'm just going to try the same usual method, and it looks promising to me. So we'll group the first two terms together, s to the third power plus 3s squared. Always start with a plus sign between your two groups. So that minus sign will stay with the 25 inside the second group. And we'll get negative 25s minus 75. Factor out the common factor in the first group. That'll be s squared. That's going to leave me with s plus 3. Factor out the common factor in the second group. It's going to be 25. But because I want this parentheses to match this, I don't want to leave these as both negative. I would like them to both be positive. So I will factor out a negative sign with the 25. And that leaves me with positive s plus 3. And so this actually has worked out because these parentheses match each other, right? S plus 3 in the first group, s plus 3 in the second group, which means these two groups have that common factor of s plus 3. So we can factor that out. We'll factor out the s plus 3, which will go first. And then what's left over is s squared minus 25. So let me write that again. I didn't like how I wrote that 5. Let's try that one more time. Okay. And don't forget, we had this common factor of 5 that I conveniently left out of the picture because by copying it down, it gets in the way. So we don't want it to get in the way of the factor by grouping. So I wait till I'm done factor by grouping, then I bring the 5 down. All right. So notice we factor out a common factor. That was one type of factoring we did. Then we did factor by grouping because there was 4 terms. So that's how I know to do factor by grouping. And I get to this point. So I've done 2 layers of factoring so far, and I'm still not done because this can be factored again. Right. We have 5, s plus 3, and then s squared minus 25. I'm just going to copy it again up here so I can finish the problem. And the s squared minus 25 fits the a squared minus b squared formula again. Right, and so that will factor as s plus 5 times s minus 5. All right, so it's using, instead of, well, let me just write out the formula. I'll just do this one more time. I don't want to do it every time necessarily. So hopefully you've used this formula. Notice how many times we've used it so far in this lesson. But you'll use that formula quite a bit to the point where you'll get the hang of it. And for at least the simple cases like this, you'll be able to use it pretty easily without having to write out a whole bunch. But it just takes a little bit of practice. But what we're doing here is instead of a, we have s, and instead of b, we have 5, right? We rewrite the 25 as 5 squared, and instead of b, we have 5. So that's why this becomes s plus 5, s minus 5, which is what I wrote here. And none of these can be factored any further. So this problem had 3 layers of factoring to do. Factor out the common factor, factor by grouping, factor using a formula. We had to do all 3 of those to get to the right answer. All right. All right, so this one, again, we have 2 terms in this case. So I know I'm going to have to use a formula at some point. But before I do that, I'm looking for a common factor. And we do actually have a common factor here. This one's kind of tricky. There's a lot of stuff going on here. So it looks like they both have a v. So I can factor out a v. The lowest power of v is v to the second power. They also both have a q. So I can factor out a q. The lowest power of q is 2. So that's the most I'll be able to factor out. So if I take away 2 powers of v and 2 powers of q, what I'm left with here is v squared. Minus, we'll have the 25 because we're not doing anything with the numbers. I'm taking away 2 powers of v, so that's gone. 2 powers of q, so I'll have a q squared left over. So that's factoring out the common factor. Right? So now this fits the a squared minus b squared formula. Instead of a squared, we have v squared. And this has to be written as one thing squared in order to fit it into the formula, right? The formula is a squared minus b squared. It's one thing squared minus another thing squared. So this term has to be written as one thing to the second power. So what is that one thing going to be? It's going to be 5q, right? Let's try that again. Let's try that 5 one more time. 5q, right? 5 squared gives me the 25, and then q squared gives me the q squared. And so this will factor, again, I'm not going to write out the whole formula this time. Hopefully, we've seen it so many times already in this video. It factors as a plus b, a minus b. But instead of a, we have v, plus, instead of b, we have 5q. So I'm going to get a plus b, and then a minus b. Instead of a, we have v, minus, instead of b, we have 5q. And then we copy down the common factor, v squared, q squared, and we look to see, is there anything else that I could factor here? And it doesn't look like anything else is going to factor any further. So this is as far as we can take it. All right. Let's take a look at another example. All right. So this one's kind of like one we've seen already. We saw this when we did the special factor by grouping that we did earlier. And so this is kind of the same boat. We have two squares here, but one of the squares is a little bit more complicated. So let's rewrite the 81 as 9 squared minus p minus 4 squared. So this fits the a squared minus b squared formula. Again, we've seen it in almost every single problem we've done in this video. This will factor as a plus b times a minus b. I'm going to write it out this time because this one's a little more complicated. Instead of a, we have 9. Right? So we're going to replace the a with a 9. And instead of b, we have p minus 4. So I'll get p minus 4 here. All right. Yeah, I guess I'm happy with that. And we'll do the same thing in the second factor. Here's where it gets a little bit tricky. Instead of a, we have 9 again. Minus, it's that minus sign that makes it tricky. Instead of b, we're going to have p minus 4. But because that's two terms, and we want to subtract whatever b happens to equal, we want to subtract that whole thing, we need to put parentheses around it. And we're going to have to distribute that minus sign. All right, so that minus sign will have to get distributed here. And so we'll end up with 9 plus p minus 4. And then we'll have 9 minus p plus 4 when we distribute that negative sign. And one other thing that's a little bit different about this problem is this one can actually be simplified. These numbers can be combined together. So 9 minus 4 gives me 5 plus p. And then 9 plus 4 is going to give me 13 minus p. And you need to do that in order to get the exact correct answer. So on Math Excel, if you leave it like this, it's not going to give you credit for that. You need to simplify by combining those numbers together. All right, so that's a little bit different than what we saw before because previously nothing could be simplified when we had that situation happen to us on the earlier example. So like this one, right? So there's no like terms here. V, Q, and 8, nothing can be combined together. So that's why we just left them all separated out like that. But in this example, the numbers could be combined together. So you want to simplify if possible, right? If you have like terms, combine them together. All right. So I think this might be the last example that I plan on doing completely for you. Then I have a set of problems for you to try out. And then following that, I'll have some answers for you so you can check to see if you're doing it right. So again, we have 4 terms here. So I'm going to use factor by grouping. I've already got that idea in my head. But before I jump into factor by grouping, let's look for a common factor. And it's kind of a funny one. It's the number here, 3, which is just the same all the way through. So we can factor that 3 out. And it almost looks like you could do more. You might think, what about W? Well, the last term doesn't have a W. So you can't factor a W out from this because the last term doesn't have it. And same thing with F, right? It looks like F might be a common factor, but it's not present in the first term, which means we're not going to be able to factor out F either. So all we can do is factor out a 3 here, but it's important that we do that to get the right answer. So factor out a 3 leaves me with W to the 3rd power minus W squared F minus WF squared plus F to the 3rd power, right? The 3 is just gone from all of those terms. All right. Now I'll try factor by grouping. I'm going to try it in the traditional, usual way. I'll group the first 2 terms together. Always start with a plus sign between your two groups. That minus sign will stay with the w inside the second group. And so I'll have negative wf squared plus f to the third power. We'll factor out the common factor in the first group, which is w squared. That'll leave me with w, right? There's 3 powers of w here. Taking away 2 of those, so I'll have 1 w left. Minus, take away both powers of w here, so all I'll have left is an f. Here, the common factor will be f to the second power, right? So I'll take away both powers of f there, and there's 3 here to begin with. I'm taking away 2 of those, so there'll be just f to the first power left. And the reason I'm not writing it in yet is because I wanted to point out that we're going to also factor out a negative sign with that, so this will become positive w minus f that we have left over. All right, so we take away the negative sign, take away the f to the second power, it leaves me with a w. All right, and again, this is critical, these are the same. So for these two groups, we have this common factor of w minus f, so let's factor it out. We'll factor out the w minus f. That leaves me with w squared minus f squared. Don't forget your common factor of 3. We don't want to leave that out of our answer, so let's go ahead and bring that down now. I didn't bring it down earlier because I didn't want it to get in the way of factor by grouping, but now that I'm done with factor by grouping, we need to bring it back into the picture. And then this can be factored using the a squared minus b squared. So we saw something very similar to this earlier, right? And so this will factor as 3w minus f. This will factor as w plus f times w minus f. Right? Instead of a, we have w. Instead of b, we have f. So it factors as a plus b, a minus b. And you should be okay leaving your answer like this. Right, so this is factored, and there's nothing else we can do. There's no more factoring that can be done. But you could write, you have 2 factors of w minus f. So you could actually write this as 3w minus f squared, because there's 2 of those, and then w plus f. So this would be another way of writing the same answer. But I think Math Excel should accept either of those. All right. Let's take a look at the next screen here. So here are some problems for you to try. So if you will, pause the video and see if you're able to figure out the answers to these problems. Remember to be persistent. So don't just do one kind of factoring and quit. You do one type of factoring, you see what results, and check to see if anything can be factored even more. And if there's anything else that can still be factored, you need to go ahead and do that. Also, keep in mind that if there's 2 terms, there's a formula to help you factor that, most likely a squared minus b squared. So that's going to help you on these 2 problems. If there's 4 terms, like you see down here, you're going to have to use factor by grouping. And let me just warn you, this one here, you don't want to do factor by grouping in the usual way. You have to do the unusual method of grouping 3 together. But this time, at least, you don't have to rearrange the order of anything. So just group the first 3 terms, and then you should be able to get it from there. And then this one's kind of, a pretty straightforward case. So I'm not going to say much about that. So pause the video, give those 4 problems a try, and then resume the video so you can check to see if you got the right answers. All right. And so here are the answers, the results for these problems. So I'll go through them really quickly. I just put them all on the screen here real quick. And I know it might be hard to kind of parse out, especially if you had some trouble doing it on your own. But what we did here was factor out the common factor of 3. That leaves you with t squared minus 4t minus 12. And then this one can be factored using the shortcut. Find 2 numbers that multiply to negative 12 and add to negative 4. That's going to be negative 6 and positive 2. Those are the 2 numbers that go in my 2 factors. And so this will be your final answer here. For this one, there's no common factor, so we can just jump right into using the formula of a squared minus b squared. I'm rewriting this as a to the 4th power squared minus g to the 4th power squared, right? Because in order to use that formula, you have to have one thing squared minus another thing squared. And so that's how you would have to rewrite this. And so instead of a, you're going to have a to the 4th power. And instead of b, you're going to have g to the 4th power. So this is the a plus b right here. A to the 4th plus g to the 4th. This is the a minus b. But then this one, the a minus the a to the fourth power minus g to the fourth power, can be factored again. It again fits the a squared minus b squared formula, except that you would have to write it as, this would be a squared to the second power. So I've already done so much writing on this screen, it's starting to get laggy on me. Let's try this again. G squared to the second power, right? So you have to rewrite both of these as something to the second power. All right, and so a to the fourth power can be written as a squared to the second power. G to the fourth power can be written as g squared to the second power. And then you use the same formula again, a squared minus b squared. It'll factor as a squared plus g squared, a squared minus g squared. And then again, this one can be factored using the same formula, a squared minus b squared. It breaks down to a plus g times a minus g. And then these just get copied down because with the plus sign, these actually cannot be factored any further. Right, so a squared plus b squared doesn't factor. It's only when it's a squared minus b squared. This one seems like there might be more to it than there really is. You factor out the common factor of 3 first, right? Then you have two terms here, so you're going to use a squared minus b squared. Same as kind of what we did up here. This s to the fourth power is written as s squared to the second power. And then 36 is 6 to the second power. So instead of a, you have s squared, and instead of b, you have 6. And so you're going to get s squared plus 6, s squared minus 6. And that's all you can do with that, because the 6 cannot be written as a square, right? So this does not fit back into the a squared minus b squared formula, so there's no more factoring you can do with this. So even though this looks like something that could be factored further, it doesn't, because the 6 ruins it. If this had been a 16, well then yes, we could factor again, because 16 is 4 squared. But because it's a 6, there's nothing else you can do with that. And then this one I already gave you a hint on. You group the first 3 terms together, and then you're going to factor this. You want two numbers that multiply to 81, add to negative 18. That's going to be negative 9 and negative 9. So you get x minus 9 times x minus 9, which you can write as x minus 9 squared. Not only can you write it like that, you must write it like that in order to figure out the answer in this case. So you'll take x minus 9 times x minus 9, write it as x minus 9 squared, and then you still have the minus y squared. And so now this fits the a squared minus b squared formula, except that instead of a, we have x minus 9, and instead of b, we have y. So this is going to be the a plus b right here. This is the a minus b right here. Instead of a, we have x minus 9, and instead of b, we have y. Same thing here. Right, so this is what you would get. And then, of course, we'd want to simplify this, but there's no like terms, so there's nothing to simplify. So this is, you just leave the answer in that form. All right, so that concludes section 4.7, which is on factoring strategies.